Hey guys, I just wanted to remind you of what we learned on Friday, so before you start your homework you'll have kind of a quick refresher. Remember, we looked at multiple zeros on Friday. What are multiple zeros? Those are zeros that occur more than once. That occur more than once. What is the multiplicity then? The multiplicity is just how many times it occurs. So multiplicity, how many times the zero occurs. So this is an example of what you might see. If we have y is equal to x plus 3 squared, the 0 here would be what value of x would set the equation equal to 0. So that value would be negative 3, because if you plugged in negative 3 plus 3 would be 0. And that would set the whole function to 0. But now, since we have an x plus 3 squared, you can think of that as x plus 3 times x plus 3. That's what's said to be a multiple zero. What would the multiplicity be? The multiplicity would be how many times it occurred. So the multiplicity here would be 2. Now, why is this helpful? What does this look like graphically? Multiple zeros kind of give you a shape of your graph. For example, if I have something like y is equal to x plus 2 times x plus 3, then there's no multiple zeros there, so I know I'm just going to have a 0 at negative 2 and negative 3. And then I would just have a parabola that goes like this. Essentially, if you have a 0, or if you have a 0 where the exponent is odd, like this was both to the first power, then you know, so I'm going to write down odd, then your graph will pass through the x-axis. So it's nice. This gives us a shape. We know that we have a 0 at negative 2 and negative 3, so the graph's going to pass through the x-axis. However, if I have something similar to this, like y is equal to x plus 2 squared times x plus 3, now I have one even power and one odd. And so if I take a look at how will this affect my graph, I still have zeros at negative 2 and negative 3, but now I know that since the negative 3 has an odd power, it's going to pass through. But since negative 2 has an even power, the graph's going to bounce per se. Look at how that bounces. And then this one was an odd power, so it passed through. So that's just nice to see. How can multiple zeros, how can they show us how it will affect the graph? If it's even, it's going to do a little bounce. If it's odd, it's going to pass through. So your homework is mainly saying, can you recognize multiple zeros? So let me just take a look at letter A. Find any multiple zeros of the function, state the multiplicity. Well, if I looked at the 0 here, this one would be x equals 2, but that's not a multiple zero because that x minus 2 factor does not occur more than once. If I look at this, however, x equals negative 1, it occurs here, and if I think of x plus 1 squared as x plus 1 times itself, then I see I have another, well, the same 0 at negative 1 3 times. So since it occurred 3 times, my multiple zero would be negative 1. And the multiplicity, how many times did it occur, would be 3. Now looking at letter B, this one's in standard form. So how do I work backwards and see where are my zeros? I need to put this back into factored form. So if I put it into factored form, first I see what's the GCF, what can I take out of all 3? That would be an x cubed. And taking that out, it would leave me with an x squared minus 6x plus 9. Now I continue factoring. I see what multiplies to be 9 but adds up to be negative 6. That would come out to be negative 3 and negative 3. So this function factors down into x cubed times x minus 3 times x minus 3. Now I see 2 multiple zeros here. One, if I set x equal to 0, then I would get 0 times a number, 0 cubed times a number, which would set the function equal to 0. So x equals 0 is a multiple 0, and x equals positive 3 is also a multiple 0. If you're wondering how did I get that, you set your factor equal to 0 and solve. So I have x equals 3 and x equals 0. So here's a multiple 0. What's the multiplicity? How many times did it occur? That would be 2. X minus 3, x minus 3, so the multiplicity would be 2. X equals 0 is a multiple 0. How many times did it occur? Well, we had x cubed, so the multiplicity would be 3. So if we think about this graphically, since this is an odd power, I know that at this 0 value, my graph would pass through the x-axis. But since this is an even power, x minus 3 squared, that would be, I know it's going to bounce off of the x-axis. Last thing I wanted you to take a look at before you start your homework is if you could flip it over to page 6 of your notes. This last example here. Write a polynomial function in standard form given the zeros. So now we have the answers for what our zeros are. X equals 2, x equals negative 3, and x equals 0. Notice they didn't say any of those were multiple zeros. So to put this back in standard form, we need to take it back and see where did these 0 values come from. Well, if I think about making this back equal to 0, I have x minus 2 equals 0, add 3. I have x plus 3 equals 0, and then I just have x equals 0. So here's where they came from, these factors, x minus 2, x plus 3, and x. So to put it back in standard form, x minus 2, x plus 3, and I'm going to move the x to the front, then I would just take these factors and multiply them back out and see what's the function in standard form. So we distribute this x, giving us x squared minus 2x, and then we need to multiply this entire term by x plus 3, so we're going to need to FOIL. First times first is x cubed, outer times outer is 3x squared, inner times inner is negative 2x squared, last times last is negative 6x. Combine the like terms, and we'd see that this function was x cubed plus x squared minus 6x. So that's the function in standard form, of which where these zeros came from. And that's it. You guys can go ahead and start your homework.